October 3, 2025. While the Perseverance rover quietly captures 20 frames of the Martian sky, the only sign of the tri-eyed Atlas, an interstellar alien, is a faint, blurry spot where it should be. However, at the moment when the world demands answers and high-quality images from orbit, nearly 15,000 NASA employees suddenly go on forced leave, and all official channels fall silent. This is the perfect storm: unprecedented anomalies, wild theories about a cylindrical object, and communication failure at the moment when the last images show something strange related to the three-eyed Atlas. But what is hidden? And why does each new statement seem to contradict what we thought about interstellar objects? The story begins with a single blur, but unfolds into something unexpected. For several hours after the Perseverance images appeared online, one frame, barely more than a weak blur, ignited a digital wildfire. Cities and astronomers began to study raw data, overlaying the predicted ephemeral trajectory of the three-eyed Atlas onto the Martian sky. The coincidence was striking. The spot was exactly where the Kineos teams had indicated, yet the ambiguity of the images was irresistible. On social media, users outlined a long object with thick red oval lines, calling it a cylinder or cigar, and urging others to enhance the pixels. Within a day, the meme mutated. Now the object had become a Martian monolith, a spaceship, or even a cosmic flash drive. The original 20-frame composition was dismantled and reposted with every possible filter. Some discussions claimed to have noticed traces on the surface, others insisted on a metallic sheen, and some even began to draw shadows, constructing evidence of artificial geometry. Investigation enthusiasts began comparing Perseverance data with older images of comets, claiming that no known comet has ever looked so perfectly straight. Each new repost added another layer of speculation, and soon the narrative about the cylinder overshadowed the technical explanations of cosmic ray impacts or image noise. Astrometric overlays circulated in scientific Discord servers, where some users carefully matched the angle of faint lines with the predicted movement of the three-eyed Atlas. The coincidence turned out to be close enough to satisfy some, but for others, the lack of high-quality images from orbit became a real mystery. Why, they asked, do the only available proofs come from the surface when entire fleets of orbital spacecraft with powerful cameras are on Mars? As the meme gained popularity, an increasingly broad network joined it: space enthusiasts, skeptics, and conspiracy theorists. The lack of official images only fueled the fire. Every unasked question was met with a new viral post, as the lines between genuine inquiry and online spectacle blurred. In the vacuum of silence, speculation thrived, and demands for answers grew louder with each repost. In August, long before the topic 3I/Atlas became relevant, Bertie Dorsky and her remote sensing team gathered with a sealed envelope and a set of coordinates. In session logs dated and published days before the images of Perseverance appeared, there was something strangely specific mentioned. A device the size of a flash drive was inside a much larger icy object. According to transcripts, this item was not inert. It pulsed, sending regular directed impulses. The motif of a technological core hidden in a comet-like shell recurred in several blind sessions, each conducted without knowledge of the purpose. What stands out is not only the scale of the device or the motif of pulsation, but also the language used. Participants in the session described the camouflage as if the true nature of the object was intentionally hidden, mentioning graffiti on the surface or inscriptions, details that later became the subject of online debates about artificial geometry and signs in the Perseverance dataset. The overlap of facts is impressive, but the temporal aspect is also important. These motifs appeared in records from August, a few weeks before the first public hints about flybys past Mars or the viral meme with the cylinder. Nevertheless, remote sensing is not recognized as a scientific method. His claims, no matter how detailed or predictive they were, cannot replace direct measurements or peer-reviewed data. On October 1st, NASA announced a partial shutdown. About 15,000 employees, engineers, data analysts, and science communicators were officially put on leave, leaving only a minimal team to maintain the International Space Station and Artemis systems. For Mars, this meant a sudden halt. Campaigns for obtaining images for 3I/Atlas were on schedule, but the teams that process, calibrate, and publish these images were mostly unavailable. The raw telemetry stream continued to arrive from orbital and ground devices, but without the usual channel, what reached the public was incomplete and unverified. Digital debt accumulated with each orbital pass. The Deep Space Communication Network continued to perform scheduled passes, transmitting fresh data packets from MRO, Mars Express, and TGO. However, each signal was met with a muted response. The research centers in Pasadena and Darmstadt operated with minimal staff, most personnel disconnected from their systems. Automated scripts archived data, but a manual check revealed a number of problems, indicating errors, compression artifacts, and suspected cosmic ray impacts that could not be resolved without the full team present. ESA confirmed that their Mars Express and TGO launches were successful but delayed publication, citing the need for interagency verification and artifact analysis. As a result, a vacuum formed that quickly filled with rumors and discontent. In this emptiness, Avi Loeb embedded himself, whose media appearances became a focal point for calls for transparency. He insisted on the immediate release of all images from Mars, claiming that the weak signal from Perseverance, although intriguing, requires independent verification from a fleet of high-resolution orbital spacecraft. The list of anomalies compiled by Loev, which was discussed in podcasts and news segments, prompted agencies to take action. Meanwhile, disagreements were growing online. Amateur astronomers exchanged tracking schedules and operational memos, trying to piece together the missing picture from what they could find. Operational paralysis turned the usual flow of data into a high-stakes game, where each hour of silence deepened both the mystery and the public's impatience. Now, 3 anomalies define the riddle of 3 Icelandic objects, each measured and studied by teams worldwide. The first anomaly is mass. Astrometric data confirmed by CNES shows a core with such a large mass that, even when emitting gas, its trajectory changes by less than 15 meters per day squared, which is barely noticeable compared to ordinary comet deviations. The second anomaly is that images from Hubble show a comet stretching towards the Sun, rather than away from it, as predicted by the physical laws of solar wind. Instead of leaving dust and gas behind, its tail points directly at the Sun, which may indicate unusual scattering or possibly an active thrust. The third anomaly was detected in the VLT spectrographs, which recorded strong emission lines of nickel, while iron was virtually absent. In comets within the solar system, iron and nickel are usually found together. However, nickel predominates here, resembling a chemical trace from industrial waste rather than space debris. Laboratory tests confirm this ratio, but no known process can explain it. The fourth anomaly is related to polarimetry. At a phase angle of 7 degrees, the polarization is minus 2.77%, with an inversion around 17 degrees, significantly exceeding the norm for catalogued comets. Several teams noted these readings as anomalous and unclassifiable. The fifth anomaly concerns the orbit. 3 Icelandic objects follow a trajectory with nearly zero inclination, approaching the ecliptic and passing close to Venus, Mars, and, if forecasts are correct, Jupiter, all in one solar pass. Such a low inclined trajectory is statistically rare for an interstellar object. The sixth anomaly is time. Ephemeris calculations show that the object's approach coincides with rapidly following planetary conjunctions. The probability of such a coincidence happening by chance is extremely low unless the input was intentionally aligned long before the opening. Finally, the overlay of coordinates places the trajectory at 9 degrees from the WOW signal received in 1970, which, albeit indirectly, fuels speculation and prompts targeted radio observations in December. In total, mass, coma, chemistry, polarization, orbit, time, and position in the sky. These anomalies defy simple explanation. The next step involves rigorous testing at perihelion and during the December reassessment to determine if this is a coincidence or a sign of something unprecedented. October 29th is a critical date. Perihelion, when 3 Icelandic objects come closest to the Sun at a distance of 1 whole 36/100ths of an astronomical unit. For several weeks, every anomaly and every rumor converges at this moment. Martian orbital probes, which have not yet gone public, must capture their highest quality footage as the object accelerates to nearly 68 kilometers per second. However, the test is not limited to a single day. Starting from November 2nd, the JUICE spacecraft begins its special observational window, providing an unprecedented opportunity to observe consequences from a unique point in deep space. For nearly 3 weeks, the JUICE set of cameras and spectrometers will scan the space for emissions, fragmentation, or any signs of unnatural activity. This campaign is confirmed by the European Space Agency and monitored by mission planners in real time. As the sunlight begins to fade, ground-based telescopes prepare for renewed observation in early December. David Farnokia from the Center for Near-Earth Object Studies at the Jet Propulsion Laboratory calls it a true solution. Only with new data on parallax and trajectory will the team be able to confirm or deny claims of non-gravitational acceleration. December 19th, when the 3i Atlas approaches Earth at a distance of 1.8 astronomical units, will be the final checkpoint. A global network of observatories, radio telescopes, and astronomy enthusiasts is preparing to record the result. The calendar is already set. Each date brings a new layer of verifiable data, moving history from the realm of assumptions to the field of measurements. Peer-reviewed SETI calculations provide concrete figures on the question of the presence of artificial signals. To reproduce a WOW-class radio beacon from the far edge of the solar system, say, at a distance of 600 astronomical units, the transmitter will require a power of at least 1 megawatt, and sometimes much more. This is the energy consumption of a small city, focused in a narrow beam and directed with precision. For any icy body drifting in deep space, this requirement raises doubts about reality unless an obvious source of energy is found. Neither a comet, nor an asteroid, nor any natural process can generate such directed radio power. The debates about the probability of the existence of a tri-eye atlas now depend on how to assess the set of anomalies, mass, nickel chemistry, the direction of the coma, and orbital alignment. Bayesian analysts start with an extremely low probability of artificial origin, less than 1 in a million. They then wonder if each new outbreak is truly independent. If so, the odds change drastically. If not, the case remains weak. The main SETI researchers warn against multiplying probabilities without clear separation. 7 anomalies in one object sound dramatic, but if each of them is not only real but also unrelated, the cumulative chances hardly change. For now, the only honest indicator of confidence is set at not impossible, but not yet convincing. The next round of data will determine whether this is a cosmic coincidence or something that completely redefines the odds. Microasteroid 1225 TF flew just 419 kilometers above Antarctica on October 2nd. Its size ranged from 1 to 3 meters in width, which is small by cosmic standards, but close enough to touch the edge of catastrophe. The warning came too late. 6.5 hours after its closest approach, the Minor Planet Center confirmed its passage. Given that the orbital calculations are quite uncertain, the object received a condition code of 7 out of 9. No warnings, no tracking. Just a quiet, swiftly moving guest. Planetary defense commands are left wondering how many more such objects have slipped by unnoticed. On Mars, the Perseverance rover's sensors detected something almost alarming, but much more reassuring. In the regions of the Bright Angel and the Sapphire Canyon, researchers discovered organic substances tightly bound to vibionite, a blue iron phosphate mineral known for its ability to preserve biosignatures on Earth. The SHERLOC and PIXL tools of the rover meticulously mapped these spots. The spatial intersection between organic molecules and minerals sensitive to redox reactions is the strongest hint that chemical traces of life could have existed or been preserved on ancient Mars. An article in the journal Nature Geoscience calls this the most promising candidate for biosignature ever discovered on the red planet. Nevertheless, with NASA's funding stuck in political uncertainty, even plans to return samples that could confirm this are at risk. At the same time, the sun shows concern. A series of coronal holes released streams of solar wind reaching 700 kilometers per second. Small coronal mass ejections move with the fast wind, causing G-level geomagnetic storms and auroras visible even at latitudes up to 40 degrees. Space weather forecasts warn that this could be the last flare before solar cycle 25 begins to quiet down. The final breath, but with enough energy to light up the skies of the mid-latitudes and test the resilience of satellites around the world. In the Congress meeting room, a screen lights up with an unpublished video. A spherical object filmed over Yemen withstands a Hellfire missile strike and continues to move. The official reaction is silence. It is claimed that the whistleblower faced persecution for reporting cases of unidentified flying objects, and the Ministry of Defense provides no explanations. Debates cover all platforms, mixing uncertainty with fascination. In the night sky, 3 green comets compete for attention. C2025, known as Lemon, becomes brighter in view, with forecasts predicting its brightness at the fourth, possibly even third magnitude. This is a rarity for any comet in recent years. SWAN after perihelion is favorable for southern observers, while ATLAS still weakly rises on the northern horizon before dawn. Each of them owes its emerald color to diatomaceous carbon and cyanogen, molecules that fluoresce under sunlight's ultraviolet light. For a short time, astronomy enthusiasts can see all three comets, a triad not observed since the early 2000s. Meanwhile, the flight of the Starship 11 is reviewing the script for reusable rockets. Booster B-15 perfectly executes a multi-stage landing, while Ship 38 experiences intentional removal of thermal protection tiles and is still restarting its engines. The simulated payload completes the checklist. This marks the end of the V2 era. Future launches will use the heavier and more reliable V3 design, promising even greater payloads to orbit. The Chinese Tianwen-2 is en route, targeting Coma Oalewa, a quasi-satellite that may be a fragment of the Moon. After collecting samples, the spacecraft will head to the active asteroid 13-1 as part of a decade-long dual mission combining lunar exploration and comet study. However, these achievements unfold against a backdrop of institutional risks. 15,000 NASA employees are on forced leave, with only 3,000 remaining to support the International Space Station and Artemis missions. Proposed cuts threaten to cancel an entire generation of scientific missions, raising concerns about brain drain as researchers seek opportunities abroad. The future of U.S. leadership in space now depends on both political will and technical ambitions. On October 3, 2025, the Perseverance spacecraft detected a faint spot in the predicted position of 13-1 during its closest approach to Mars. At a distance of 29 million kilometers, more than 15,000 NASA employees were on forced leave, leaving high-quality images from orbital spacecraft unpublished. Scientific teams have recorded 7 main anomalies: a coma rich in carbon dioxide, nickel without iron in the gas, light expansion towards the sun, and an unusual angle of polarization. Despite these findings, key questions remain. Data from the orbital apparatus is lacking, the exact cause of the unique chemistry of 13-1 and the nature of its mass and acceleration. Key observation windows, including Juizhen in November and Earth in December, will provide more data, but for now, only fragmentary information is available. The story 13-1 continues to unfold, shaped by strict scientific data and operational uncertainties. Until the next release of images and spectra, the object remains a rare combination of cosmic surprise and institutional silence.